Okay, so it's not very often that I get to teach you myself, so I'm looking forward to this. Um, and so today we're looking at quotients of linear functions. It is your very last week. And so okay, so I'm back. I just thought I had changed the calendar up and things were a little bit different, but we are Monday today. You get your final exam on Wednesday. I'll probably open it up today, to be honest with you, as they are due on Thursday. And report cards are due Friday morning. So I do want to get those in. And if I give you the 4 days, you can relax a little bit, maybe get it done if you really hunker down and get it done ASAP. So that is a possibility for you. So you've got your other lesson here that is taught by none other than who you've been watching for most of this course. I have been teaching 3 math courses, so it's been quite busy of a month. So here we are. Okay, sorry about that. Hopefully I can edit that out. I realized that I had the answer key for the independent practice questions instead of the lesson. I am recording this on Tuesday night. And so it's been quite a long day. Okay, so features of f of x is equal to ax plus b over cx plus d. So if an x value is a 0 of the denominator only, this results in a vertical asymptote. So the equation of the asymptote is, I'm getting my pen out. I'm going to use a different color than I've been doing for my other class. Okay, so your vertical asymptote will be equal to negative d over c. So these two numbers here. If an x value is a 0 of the numerator and denominator, this results in a hole in the graph. So meaning it kind of skips that point. So I will show you as we graph it along. There is a horizontal asymptote at the ratio of the leading coefficients. So the equation of horizontal asymptote is y is equal to a over c, which is, in my opinion, the easiest. Forms of a hyperbola. Is the two branches of the graph of the function are equidistant from the point of intersection of the vertical and horizontal asymptotes. So once you know the shape of one branch, you can translate the point to the graph, the other branch. So you can find the x-intercept by setting y is equal to 0 and solving for x, and this will result in your negative b over a 0. And then this guy will be b over d. I'm realizing that this looks like a 0. That's a c. Okay, so we are going to take a look at this. I'm so happy to be teaching this right now because it is my love. So I'm clearing it and we're going to take a look at example 1. Okay. So to start off, we want our vertical asymptote. So by doing so, you're setting your bottom part, so your denominator, this guy, to 0, and you're going to solve for x. And so this is your vertical asymptote. So here we've got an asymptote that goes this way. Sorry, my cat just got the zoomies or something's happening upstairs, so it made me laugh. We've got our horizontal asymptote. So you are going to use your coefficients at the front. So we've got 1/1, which is just y is equal to 1. So you're going to go ahead and draw that asymptote. The nice part about your final exam is you get all of your notes, right? So that'll be fantastic. You've got your x-intercept, so you set your 0 or your y as 0. Rewrite your equation. Okay. And so this doesn't really matter. As long as the top is 0, then your whole equation is going to be 0. So you can write it as x minus 3 is equal to 0. And so x is 3. And your point's going to be 3, 0. So you can do your x-intercept right here. You're going to do your y-intercept. So you set your x as 0. Okay. And that will give you 3/2. And so your intercept is negative 1.5, in other words, which is right there. Or sorry, my goodness. Which is not there because it is negative. It's right here. Okay, and then we want another point that will help us graph this guy. Okay, so we can set x is equal to negative 1.5 into our equation. Plus 2, which will give us negative 4.5 over 0.5, which will give us negative 9. And so if we have here, that's our other point. Okay, and so this is going to follow those asymptotes like it has been. Like that. Okay, and the reflection is going to be the same on the other side. And so this is going to be like that. And like that. And it's negative 7. Okay. That was fantastic. I really touched that point there. Okay. So I suggest that you pause the video so that you can write this down as I am about to clear it. And we're going to do one more example. Okay. So we're going to start with our vertical asymptote as usual. So you set your denominator to 0, x will be 1. Your horizontal asymptote is your coefficient. So you've got 2/1, which is just 2. I'm a little sad that we can't do the asymptotes at the same time right now because the graph is underneath. You've got your x-intercept, so you're going to set y to 0 and solve for x. That's supposed to be 2. So 2x minus 3 over, but again, that doesn't matter. So you would have 2x minus 3 is equal to 0. And so x is going to be 3 over 2. So you have 1.50. Your y-intercept, you're going to set x as 0. I miss doing this stuff. I don't get to teach this class too often. Often teaching the grade 10 applied or the grade 11 applied, or college, I guess. So it's nice to be in my comfort zone and my love. So you're going to pick 2 other points that you can graph. And so throw that into your equation and you'll get 1. And then same thing with this guy, you'll get 3 over 2. So this is a point, and this will be your next point. Okay, so write those down. I'm going to move forward with the graphing, and that is the end of this. So we said that our asymptotes are 1 for your vertical. We're going, okay. And then we've got our 2 for horizontal asymptote. Plot your points and you can connect them to get, my gosh, craziness. Okay. And then that goes like that, which is a little bit better than was. Okay. Hopefully that makes sense. If you find that because you're the only course that really got a mixture of both me and the other videos, and if you find that my lessons were a little bit better, please let me know for my future summer school classes or any online classes that I'm going to be doing. I appreciate any feedback from you guys. So good luck with your work today and your final exam. I hope that it goes well.